Hey everyone, welcome to Math 104, Section 5.2, Factoring Trinomials, Part 1. So I'd like everybody to start with a warm-up. The game we're going to be playing here is find two numbers that multiply to get C and add to get B. So in this case, we want two numbers that multiply to get 15 and add to get 8. And then when we're done with that, go ahead and factor that expression. Just a reminder, I don't stop, so pause the video to work on things and then restart it. Okay, so two numbers that add to get 15, or multiply to get 15, add to get 8, that is 3 and 5. And here we need two numbers that multiply to get 6 and add to get negative 5. Alright, so let's think this through. Any numbers that multiply to be positive have to either be both positive or both negative. Their sum is negative, so we have to be talking about two negative numbers. So that's going to be negative 2 and negative 3. Negative 2 times negative 3 is 6. Negative 2 plus negative 3 is negative 5. Now here, we have two numbers that multiply to get negative 14. The only way that can happen is if one is positive and one is negative, and they add to get negative 5. So we're going to work with negative 7 and 2. And then factoring this, we're going to pull out the x plus 5, and 2 minus x remains. X minus 5 times 2 minus x. Now this is the general form of the quadratic equation, and this is the type of equation we're going to be factoring today. So what we have here is some number multiplied by x squared, so there's the x squared term, the quadratic term. Some number times x, there's your linear term, and then a constant on the end. So when we see an actual quadratic equation, there'll be numbers here, here, and here, and the x's will stay. So here's an example, x squared plus 8x plus 12. Now I'm putting forth a proposition that equals this. All right, we got two binomials multiplied by each other, and that's what it means to factor. We take a trinomial and convert it into two binomials that are multiplied together. So what I'd like everybody to do now is confirm that this is correct by foiling here. And when we FOIL, we get x squared plus 2x plus 8x plus 12. Just kidding. Just thinking ahead a little bit there. 6x. Okay. X squared plus 8x plus 12. Alright, so when we combine like terms, we're right back where we started. So those two things are, in fact, equal to each other. So we've been doing foiling up until now, going in this direction. Now we're going in the opposite direction. Trinomial to two binomials by factoring. So how are we going to do that? We're going to use what we just did in the warm-up. We're going to find two numbers that multiply to be C. C is, in this position, the constant. And those two numbers should add together to equal B, the coefficient on the linear term. And one way to do that, some people can just factor these. The numbers just kind of appear in the head, or maybe they think through some factors. But not everybody can do that. That's a tough thing to do. So this table can be really helpful. So what we're going to do is we're going to write down all the pairs of numbers that multiply together to get negative 14. So we have negative 14 times 1, negative 1 times 14, negative 2 times 7, and negative 7 times 2. That's all the pairs. And over here, we have their sum. So add them up as we go across. And then what we want to do is pick the sum that matches the coefficient on the middle term, and that is negative 5. So we got our match. So that means these are the two numbers we're looking for. And those are the two numbers that go into the binomials. And there's the answer, x minus 7, x plus 2. So once you get your numbers, all you do is stick them in the binomials and you're done. All right, try this out with your turn number 1. So we're going to start off by finding the factors of negative 12. So we got 1 and negative 12, negative 1 and 12, and then we got 2 and negative 6, negative 2 and 6, and then negative 3 and 4, 3 and negative 4. So there's all the pairs of numbers that multiply to get negative 12. Now let's find their sums. Here we got negative 11. Here we got 11. Notice they're all going to be opposites pairs like this. Negative 4 and 4. And then we got 1 and negative 1. All right, the coefficient on the middle term is 4. So there's our match. That means our two numbers are negative 2 and 6. So the factored form is x minus 2 times x plus 6. And we're done. Number 2, factors of 20. Okay, we have a positive value here. That means our two numbers could either both be positive or both be negative. To see which, look at the sign on the middle term. It's negative. So that means the numbers have to be both negative. So that means you don't even have to write down the positive numbers in the list. So a little time saver there. All right, negative 20, so we can go or positive 20, we can go negative 1 and negative 20. Or we can do negative 2 and negative 10. Or negative 4 and negative 5. And the sums then are negative 21, negative 12, and negative 9. We're trying to match negative 9, so there's our pair, negative 4 and negative 5. X minus 4, x minus 5. Now quadratics can be quite a bit trickier to factor if the x squared term is negative. But there's an easy fix for that. We are going to factor out negative 1 from the entire quadratic as a first step. And that turns into a quadratic with a positive x squared term. Negative x squared plus 3x minus 2. Start by factoring out a negative 1. I'm just going to write that as a negative sign. You don't have to actually put the 1. X squared. Change the sign of all three terms. Alright, negative to positive, positive, negative, negative to positive. And now we've got just a regular quadratic here to factor. So we need two numbers that multiply to get 2 and add to get negative 3. Well, there's only two pairs of numbers that can multiply to get 2, and that's 2 and 1, or negative 2 and negative 1. And it's negative 2 and negative 1 that add together to get negative 3. So that gives us x minus 2, x minus 1, with a negative sign out front. Your turn, number 3. So factoring out a negative 1, it gives us x squared plus 2x minus 15. Now we need two numbers to multiply to get negative 15 and add to get positive 2. Since this is negative, one of the numbers will be positive and one will be negative. And since the middle term is positive, that means the bigger number has to be positive. Well, to get 15, we can do 3 times 5, and we'll make 5 the bigger one. Or 5 the positive one. The bigger one's positive. So that gives us negative 1 times x plus 5 times x minus 3. Now, not all polynomials can be factored. And the ones that cannot be factored are called prime polynomials. So we've got x squared plus 3x minus 6. So let's identify A and B, or B and C first. B is 3 and C is negative 6. All right, now we need two numbers to multiply to get negative 6 and add to get 3. All right, so we got factors of -6 and the sum. Factors of -6 are -1 and 6, 1 and -6, -2 and 3, 2 and -3. Those are all the factors of -6. All right, now over here we're going to write their sums. So we got 5, -5, 1, and -1. Now notice none of these in the list match the middle term. If you counter that, that means that is a prime polynomial. Just write prime and you're done. Now for showing work on these, make sure you put out the entire list, all the sums, to show that there's no match there. Your turn, number 4. So there's all of our factors of 8, -8 and 1, -1 and 8, -2 and 4. Oops. Yeah, that's right. And then 2 and -4. All right, the sums. We got -7, 7, 2, and -2. None of these match 12, so that is prime. Some of the polynomials we're working with have more than one variable. The process is going to be very similar though. All right, so we're at x squared minus 5xy plus 6y squared. All right, so we want, just like over here, we wanted two numbers to multiply to get the last term and add to get the middle term. Same deal here, except now we have an expression here with y's in it. So we need two monomials that multiply together to get that. Now, the one thing we cannot do is have one of the monomials have y squared in it and the other just be a number. Because if we add those together, I mean, we can't even add those together, so those won't work. So they have to both be y terms. So the y terms would be y and 6y. And since we have a negative in the middle term, those will be negative. So negative y and negative 6y. Then we have negative 3y and negative 2y. So of the negative versions, those are the only combinations that multiply to get 6y squared. So which one of these add up to get negative 5y? Just ignore the x for now. That'll come in later. So we're just trying to match negative 5y. That's these two that are going to add together to get negative 5y. Up here we got negative 7y. Alright, so that's our pair. Now we just fill them in exactly as we did before. X minus 3y and x minus 2y. So the process is exactly the same. You just have to remember to split it up into two y terms instead of just numbers. And if we FOIL this, we get x squared minus 2xy minus 3xy, and last, plus 6y squared. Combine like terms, and we are right back where we started. So that middle term of the x that we were ignoring before, that comes back in when we FOIL and multiply by those x's. Your turn, number 5. All right, now we need two y terms that multiply to get negative 8y squared. This is negative, so one will be positive, one will be negative. So we could do negative 8y times y, or we could do negative 4y times 2, negative 2y times 4, oops, 4y, got my y's, and then we can do negative y times 8y. All of these multiply to get negative 8y squared, and that's all the combinations that we'll do so. So now we need the sums over here. So that's going to be negative 7y, negative 2y, 2y, and 7y. Our match is 2y. So here's the two we want, negative 2y and 4y. So that gives us x minus 2y times x plus 4y. All right, some trinomials will have a common factor, and in every factoring problem it is essential that the first step is factor out the GCF. All right, of the three coefficients, greatest common factor is 2. And if we look at each of the variables, smallest exponent is 1 on the x and 3 on the y. So we're going to factor out 2x y to the third. All right, so that gives us x squared minus 24xy plus 144 y squared. All right, now we have factorable multivariate trinomial. So we need two numbers that multiply to get 144 and add to get negative 24. So this is where it's really helpful to know your times tables. 12 times 12 is 144. So those are our two numbers, 12 and 12, but negative versions because the middle term is negative. So that factors into x minus 12y, x minus 12y. Or you could write it as x minus 12y squared. Your turn, number 6. Alright, so we're going to factor out a negative 9. Factoring out a negative 9 will make the x squared term positive. And each term has one x, so we'll factor out an x as well. So factoring out negative 9x is the GCF. That gives us x squared plus 4x minus 21. All right, now we need two numbers that multiply to get negative 21 and add to get 4. The only numbers that multiply to get 21 are 1 and 21 and 3 and 7. So with 3 and 7, we'll combine to get 4. X plus 7, x minus 3. Now, as we'll see in the next section, factoring trinomials, if a does not equal 1, can be fairly tricky. So that's where we have a coefficient on the x squared term that is not 1. So let's take a look at one of those, x squared, 10x squared plus 17x plus 3. So when the numbers are small, especially if we have prime numbers, and especially if we have all positive, we can factor these by trial and error. Now, you can do them if the numbers are bigger, if you have negatives, but it just takes longer because you have more combinations. So what we're going to do is we're going to write down all the different ways that you can factor 10 and 3 into these binomials. All right, we know that when we FOIL, first times first equals this term. So we're just going to work on these first. How many different ways can we come up with 10x squared? Well, we could have an x here and a 10x here. Or we could reverse them, 10x and x here. And then we could do 2x and 5x. Or 5x and 2x. There's all the configurations of those. Now over here we have a 3. And the constant, we get that by multiplying last times last. So let's write down all the combinations of 1 and 3 that give us different combinations here. Alright, so we want to put x with 1 here and then x with 3. So we have both combinations. 10x plus 1 times x plus 3, and then the reverse, x plus 1 times 10x plus 3. So all the combinations there, and then we'll do the same thing here. Plus 1, plus 3, plus 1, plus 3. Alright, so there's every possible combination that can give us 10x squared and 3. But what we haven't yet accounted for is that middle term. So now we can FOIL and see which one produces 17x. Alright, here we got 10x and 3x, that's only 13, so that's not it. Here we got 30x and 1x, that's 31, so that's not it. Here we've got 6x and 5x, that's 11, so that's not it. Here we have 15x and 2x, that's 17. So that's it. Now let's FOIL just to make sure. 5x times 2x squared, that is 10x squared. We got 5x times 3, that is 15x. 1 times 2x, and 1 times 3. Combine like terms, that gives us 10x squared plus 17x plus 3. So if all else fails, you can do trial and error. It's a nice backup technique, but we're going to learn better techniques tomorrow. Your turn number 7. Use trial and error to factor 6x squared plus 17x plus 5. All right, so there's all the possible combinations to get 6x squared. Now we got 5 over here. So I'm going to do 1 and 5. And then keep doing 1 and 5, plus 1 plus 5, plus 1 plus 5. All right, there's all the different combinations. Let's FOIL to get 17x. 6 times 5 is 30, plus 1, 31. Nope. X times 5 is 5x. You have 6x here, that's 11x total. No. 2x times 5 is 10x. 3x times 1 is 3x. Add them together, we get 13x. No. 3x times 5x is 15. 1 times 2, that's 17. So there we go. 3x plus 1 times 2x plus 5. And make sure to check. All right, last page, we got some practice problems. So just remember all the techniques we learned today and work on identifying the problem type and remembering the procedure. That's going to be an important skill for the exam. You need to be able to identify the problem type by sight and then recall the procedure. And then I will put up the solutions you can compare with those. And a 13, a little extra challenge on that one. Number 8. We need two numbers to multiply to get positive 30 and to get negative 11. Alright, since this is positive, the numbers will either be both positive or both negative. The middle term is negative, so that means they'll both be negative. Alright, factors of 30. 30 can be broken up into negative 1, negative 3, negative 2, negative 15, negative 3, negative 10, negative 5, negative 6. Which one adds to negative 11? That's these two. So we got x minus 5, x minus 6. Next up, we have a negative x squared term. So let's factor out that negative. X squared minus 10x plus 24. And we need two numbers to multiply to get negative 4 and add to get negative 10. And that is negative 6 and negative 4. Alright, here we got a multivariate one. So we need to break this up into y terms. So we can do y times 28y. And we need to make them negative because the middle term is negative. Or we could do negative 2y, negative 14y, negative 4y, negative 7y. And that's it. That's all the combinations for 28. Which ones add to get negative 11? That's these two. So that gives us x minus 4y times x minus 7y. Next up, two numbers to multiply to get 60 and to get negative 11. So factors of 60 is positive, so they'll be both positive or both negative. Middle term is negative, so they both have to be negative. So negative 1, negative 60, negative 2, negative 30, negative 3, negative 20, negative 4, negative 15, negative 5, negative 12, negative 6, negative 10, 7 doesn't divide, 8 doesn't divide, 9 doesn't divide. So that's it. That's all our combinations. Now let's find the sums. We got negative 61, negative 32, negative 23, negative 19, negative 17, and negative 16. None of them match. So that trinomial is not factorable. That trinomial is prime. All right, next up, 2x to the fourth plus 6x to the third minus 20x squared. All right, clearly we've got a GCF that we can factor out of this one. All right, greatest common factor of 2, 6, and 20 is 2. Smallest exponent on the x is 2, so factor out 2x squared. And that gives us x squared plus 3x minus 10. All right, now we need two numbers to multiply to get negative 10 and add to get 3. Those two numbers will have opposite signs because this is negative, and the bigger number will be positive because the middle term is positive. So that factors into 2x squared times x plus 5 times x minus 2. All right, this is a trial and error one. The formats can be a little different on this one because we have x and y here. So that means we're going to have to try things that have something like 6xy and then xy. Or we could do 2xy and 3xy. And then we'll need to have 4s over here. This one's negative, so I'll have to account for negative and positive. So you can just write out all those different combinations. And as it turns out, what do we get? We get 3xy plus 4 times 2xy minus 1. And if you write out all the combinations and FOIL them, you'll see that this is the one that when we FOIL it, we're right back where we started. All right, so that is it for today. This is one of the most important factoring techniques. This particular version of trinomials is the one you'll see most often. Especially they tend to occur as single steps within college algebra problems. So if you've got this mastered, then you'll be all set.